Sometimes I feel throw my hands up in the air. I know I can count on you. Sometimes. So now we're going to go over the actual theorem, binomial theorem / series. Okay. So what we have, let's say you have these deal with forms like this, r plus s to the a power. Okay, so this is like I guess that's binomial form or something. That's just the name given to it. So what this is going to expand to is r to the a plus, and now here we have our binomial coefficient, right? We just learned how to calculate that. So a over 1, a parenthesis a1 thing, and then r a minus 1 times s plus a 2, and then we have r to the a minus 2, and then s squared, and then we just keep going until we get to, here I'm going to write the last two terms so you get the gist of it. R to the a minus, nope, that's not, no, hold on, going back, r, we're just going to have a single r, and then s is to the a minus 1, and our last term is going to look like s to the a, okay? So, for example, I know this looks pretty confusing, but we'll do an example to make it a little bit clearer. So our example is when r equals, let's say 1, and s equals x, okay? So what we have here is 1 plus x to the a power. So we'll have 1 plus x to the a power. That's what it's saying here. So our r is 1 and x is s. Alright, so this is going to be equal to r to the a, and we'll just keep a there. So 1 to the a, and then we have plus a1 thing. And then this is 1 to the a minus 1. We're just plugging in 1 for r, and then x for the s spot. So there's an x there. And then we have our next binomial coefficient times 1 to the a minus 2. This part isn't going to matter because 1 to any power is just 1. And then we have x squared, and then we're going to have dot 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 plus, and I'll write this part here, okay? And then we have x to the a minus 1, and then plus x to the a. And like I said, the ones are just, they're still there, but it's just 1. Okay, so here's another way to rewrite this. I'm going to expand I'll write the other form of the binomial coefficient. So this 1 to the a is just 1. And then we have a over 1 factorial times x, right? The x is there. And then plus, now we have a times a minus 1 over 2 factorial times x squared plus dot 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 plus again. Then we have a times a minus 1 times, well, actually I think I'll write out the next term. Sorry, going back. Erase. Okay, so this is plus. I'll write out the next term as well, so you see a better like visualization of where we're going with this. Over 3 factorial, and then we have x to the third. So basically, the form that we have going here is that we have our binomial coefficient, right? So a over n, and x to the n, right? Because this part here, that's represented by this binomial coefficient, and then our terms are just determined by x to the n power, right? So this is kind of like the general form, okay? And this is true for any exponent, well, in this case, with our determined r and our determined s, then this is true for any exponent a. So any exponent a, and the absolute value of x is less than 1. Okay. Alright, so let's do an example. We're finding, okay, so find to the third degree, so something raised to the, probably an x raised to the third power, in Maclaurin, So Maclaurin, whenever you see that, you should, I'm happy whenever I see that because that just means the center is 0, and that makes my life a whole lot easier. In Maclaurin expansion. And the given function is f of x equals 1 plus x to the 2/3. Okay, yeah. And then we'll have n going from, so this is what we're given. And then from this, we can determine that to the 3rd degree, that means that n goes from 0 to 3, right, to the 3rd term. That's basically what it means. Or maybe not the 3rd term, but yeah, well, up to the 3rd term, because we'll have A0, an A1, an A2, and an A3. Okay. So let's find the coefficients first. I think that's a good way to go, because then you have the coefficients, and then you can just plug them into the formula kind of thing. So our coefficients are going to be 2 over 3. So this is our A, right? Over 1 factorial. That's just 2 over 3. And then we have the next one, which is 2 over 3 times A minus 1, which is 2 over 3 minus 1, 3 over 3, over 2 factorial, which is equal to 2 over 3 times negative 1 over 3. Okay, so I'll just write that. 2 over 3 times negative 1 over 3 divided by 2, so that's times a 1/2, equals negative 1 over 9. Okay, and so that was first and the second one. And then we'll do the third one, which is, I'll just write it over here, 2 over 3 times, we found that the next one to be negative 1 over 3, and then we're going to subtract another one, so that's negative 4 over 3, okay, and then this is over 3 factorial. So we'll have, eventually, like when you do the math, you get 4 over 81, okay, and that's positive, all right? So this is like our A over 1, this is our A over 2, and this is our A over 3, that coefficient. So when we plug them in, we get 1 plus x to the 2 over 3. So this is what we're trying to find, the expansion of it. So we get, it's about, well, I guess they put about, or approximately sign, 1 plus 2 over 3. We're going to plug in this coefficient in front of x, and we're going to plug in this coefficient in front of x squared. So that'll be a negative 1 over 9 x squared, and then a plus the third one, sorry, I was thinking of threes, x to the 3, and then plus so on and so forth. So we were just trying to find up to the 3rd degree, and we did. So that's it for that question. Okay, and then one last thing that I want to mention is on page 605, I believe, at least in my book, there's a table. It's labeled Table 1. It's real original. But it has a lot of the expansions of certain functions, of like common functions that you'll need. And I find it pretty useful to look at. So you can reference that or post it and put a sticky note on it or something. So yeah, that's pretty useful. I'll put little stars by it. And that's pretty much it for the concepts video. So best of luck with the homework, and I'll be talking to you in the homework videos if you watch those.